Hi, and welcome to Algebra Examples. I'm Dr. Finch. Today we're going to be looking to find the derivative of x squared plus 5x plus 2 over the square root of x. And if you've been in a calculus class for a little bit now, you'll see this division sign here and thinking, let's use the quotient rule. Well, we can do that, but the backside algebra to clean up what comes out of the quotient rule for this is going to be really messy. So we're going to use some algebra tools to make this a little bit prettier, and then we're going to take the derivative. And after we do that, if you want to stick around, I will show you what happens when we apply the quotient rule to that right there and how ugly it looks to clean it up. So there's a few things that we're going to remind ourselves of before we get started. The first one is that when we have the symbol for the square root, a lot of times we want to change it to an exponent, especially in situations like this where we're combining exponents. We want to be able to write them as numbers rather than symbols. Second of all, if we have 1 over x to some number, we can bring that number into the numerator by putting a negative sign in front of it. All right, the last one that we are going to remind ourselves is if we have x to the a, x to the b, so you have the same base there, we can add our exponents and we end up with x to the a plus b. Those three things we're going to work with. And what we're going to do is we are going to simplify our function before we take our derivative. So we are not even going to bother thinking about derivatives for a little bit. We're going to do several steps before we do that. All right, we'll start off with our first thing. And what we're going to do, I'm going to do two steps here. I am going to, first of all, break this up. Oh, I suppose I should have said this as well. A lot of you remember this, but if you don't, remember if you have the same denominator, two things added, you can split that up, which makes our lives so much better. All right, so we can split it up into three separate terms. We are going to take that square root of x and turn it into a 1/2. And then we are going to break that 1/2 up by bringing it up. Not break it up. We are going to rewrite it by bringing it up to the numerator. And then we'll notice for two of these terms, we can actually smush those together. So 2 minus 1/2, and I'm going to use this as fractions. Fractions I encourage you to use for calculus. Decimals work, and if you're doing applied math, you will be using decimals for sure. But in general, fractions are a lot easier to work with. Now, one thing to keep in mind is when you have x and there is no exponent, that exponent is actually 1. So we have 1 minus 1/2. So this is x to the 3/2 plus 5x to the 1/2 plus 2x to the 1/2, negative 1/2. That should be a negative. There we go. And this is our original function f of x. Whew. Okay, so we did a bunch of algebra right now. We are finally ready to take our derivative. Two things to keep in mind for derivatives here. First of all, if you are taking the derivative of two things or several things, as the case may be here, that are added together, you can take the derivative of those things separately, and you're going to get the same result. So we are going to do that with each of our three terms here in our polynomial. Second thing that we are going to do is remember that when we take the derivative of x to the n, we bring our power down, and we subtract 1 to get our new power. So that's our power rule. And remember, if we have constants, I suppose I should add this on here. If you have constants times a function, your constant just kind of comes along for the ride. Needless to say, if you are taking the derivative of a constant, it's going to turn into zero. All right, so let's do our f prime of x. We are going to take our exponent, bring it down, so that's 3 halves, x to the 3 halves minus 1 half, plus our constant comes along, bring our power down, x to the 1 half minus 1. Oops, and I made an error there. That's not minus 1 half. That is minus 1. That is make our lives a lot different. Bring our power down, x to the negative 1 half minus 1. All right, 3 halves x. 3 halves minus 1. 1 is the same as 2 over 2. So 3 minus 2 is 1. So we are going to get x to the 1 half. I'm just going to change that 5 times 1 half into a 5 over 2. 1 half minus 1 is a negative 1 half. And in our last bit, our 2's are going to cancel, but we are going to have a negative sign that will survive. And this gives us a negative 3 over 2. So there's our solution in nice 3 parts right there. If you wanted to, you could make this a little bit cleaner. I think it's as clean as it's going to get. I mean, you could change it to a square root symbol or put those square roots with a negative sign in front of them in our denominator. But I would say just leave it as is. It looks pretty enough as it is. All right, so there's our solution. Beautiful. Next thing that I said that we would do is let's see what happens when we take and we use the quotient rule. So let's recall what the quotient rule says. So when we are using the derivative of a function over another function, we are going to get low d high. So g of x times d dx of f of x minus high d low f of x d dx g of x divided by low squared. So g of x quantity squared. Whew. Okay. And let's write out our original function. So our f of x is x squared plus 5x plus 2 over the square root of x. And I'm just going to write it as low d high minus high d low over low squared. Here is our low, and here is our high. All right, let's apply this. We are going to take, and we're going to have square root of x, f prime of x. We're taking our derivative here. D dx of our high is 2 minus, leave the top alone, square root, or not, derivative of our square root of x times the square root, or divided by the square root of x squared. So this gives us x, and I'm going to change that to a 1 half. We're going to use the terms that we had before. Our 2 comes down, subtract 1, so it's 2x plus 5. Our x disappears here, and our 2 is going to disappear completely because it's a constant. Minus x squared plus 5x plus 2. Our derivative of this right here, this is d dx of x to the 1 half. So it is going to turn into 1 half x to the negative 1 half. No derivative on the bottom, but our square root and our squared are going to cancel out. So this is the derivative. And again, there's a lot of algebra. If you want to pretty this up, there's a lot of algebra that you have to do. Here's what happens when we have our quotient rule involved. And if we go back to our other page, here with just the 3 terms is what happens when we do our algebra up front. So this is a good demonstration of why sometimes it's good to know our algebra rules. Thank you so much for listening.